Welcome to everyone. I'm going to just talk for the first sort of quarter of an hour, 20 minutes about geospatial projects and sort of our view from a local authority. And I speak here as the Historic Environment Record Manager at Shropshire Council. So I'm responsible within Shropshire Council for maintaining our historic environment record. It's an ever-developing resource on the historic environment features of the county, be they historic buildings, archaeological finds and features, historic landscapes. And ultimately, geospatial data, managing geospatial data is at the heart of what we do. And I'm responsible for ensuring the data is delivered to both our officers within the council from a planning perspective, but also with external contractors having access to geospatial data. So having high quality geospatial data, I would argue, is fundamental to the way that we manage, conserve and record the archaeological resource as well as the historic built resource of Shropshire. Having geospatial data at our fingertips really is kind of crucial to our delivery model here in the county. But what I want to talk about is the explosion of digital data, the explosion of digital geospatial data, which, does have some significant opportunities, which I'll hopefully highlight, but also does bring some challenges working within a local authority setting, which I won't bang on too much about, but want to just have at the back of our minds when we're thinking about some of these projects. So as I said, the historic environment record, wide remit covering, 35,000 plus archaeological sites, historic buildings, landscape features, and it's continuously developing. So the information base relies upon an interchange of information with a wide range of practitioners recording historic buildings, recording archaeological features, mainly in advanced development, but also working with citizen science projects, community groups who are looking at different sources of data to try and analyse archaeological features as well as historic buildings. And sort of it goes back into the past, as John was saying. We've been involved in kind of what we in archaeological terms called remote sensing for probably about 100 years in terms of aerial photography. So aerial photographs, for instance, I feature here, are a substantial feature of how we identify and catalogue archaeological sites in the landscape, both ones which survive as earthworks, above ground features, but also where marks are made by crop formation, showing indicative of below ground archaeological features. And in Shropshire, we're lucky to have a very long legacy of flying, with aerial survey carried out since the 1930s. The map on the right of the slide indicates, where those hotspots are of data collection. So you can immediately pick out some kind of archaeological features, particularly along Offers Dyke, for instance, in the northwest of the county, and around Wroxeter, for instance, the fourth largest town in Roman Britain, with a substantial hinterland full of particularly things like Iron Age enclosure features, farmsteads, that sort of thing. A wide range of archaeological features recorded on these aerial photographs. We probably hold about 40,000 aerial photographs, sort of in traditional format. And the attempts at them were, to map these features were consistent, but they were analog. We're talking about, raster formats rather than vector formats, if you like, in GIS terms. And the mapping is accurate to a particular scale and certain resolution. So we're very familiar with collecting this information. Increasingly, the turn has been towards the digital with regards to aerial photography. So we're very lucky in Shropshire to hold a collection of nearly 10,000 digital photographs thrown through a series of projects funded by Historic England over the past decade and a half, really. These are an amazing resource, really, which allow us to map in detail these features. They are high resolution. They are a fantastic resource that we use every day. I've just put up there a bit of a sort of caveat about, that this produces wonderful images, but the digital cameras produce huge files. We're talking, archival TIFFs, which can be, 100 megabytes in, for a single file. And we are charged in the local authority with making this information available, and we, creating this data in reusable formats that we can share is a key sort of driver for how we run our service. If we're to share these images and to make them available for interpretation, reinterpretation, and use within ongoing archaeological projects. And I will talk, and I make no excuse for talking here about LiDAR, because LiDAR is a incredible technology which really is, in archaeological terms, allowing us to make new developments and create and really sort of take forward interpretation of features, particularly earthwork features in the upland zone. And Shropshire is a county which is blessed with a significant amount of upland zone. So LiDAR plays a major role in our remit to manage, conserve, identify archaeological features, earthwork features. Obviously, LiDAR will be familiar to many of you through flood risk mapping, and that's how it is originally collected, and it's why the vast majority of the LiDAR we make use of is collected by the Environment Agency. But actually, its archaeological use has really blossomed over the last decade, from all across the country, and it seems to present a very presentable, very usable kind of format for understanding archaeological earthwork features, when you can process these things as a hillshade, when you can visualize them, to assist you in understanding these features. And particularly useful, often misquoted as being able to see through trees, but LiDAR, through doing bare earth returns, is able to actually look at, through certain forms of canopy. It's able to pass through those canopies, and that's particularly helpful for the wooded areas of the county as well. So places like the Clun Valley, for instance. So I'm sure you'll be very familiar with how it works. Basically, a plane taking airborne laser imagery in swathes across the countryside, and the map on the right indicates the availability of 1 meter LiDAR coverage kind of across from the Environment Agency. So this is 1 meter resolution. So we're now sort of moving towards kind of almost 2/3 of the county covered by high resolution 1 meter imagery, and the increasingly sort of vibrant national LiDAR program, sort of led by the Environment Agency, is really pushing that one forward to total coverage of the county, hopefully within the next few years. So really changing the way we kind of look for and look at archaeological earthworks. But I think there need to be some big caveats in the way we understand and use this data. Not big caveats, but just reminders. I think LiDAR is fantastic at appearing to make self-evident kind of earthwork features, and I think we need to have at the back of our minds that it's identifying all earthwork features, whether they're archaeological or not in nature. So we have ongoing discussions with lots of volunteers, lots of interested parties across the county who are using it for citizen science recording, who are, very, very keen on identifying features. But it requires detailed analysis and understanding to enable our interpretations to be robust, essentially. And like any other survey technique we use conventionally in archaeology, it needs to be viewed against other survey data to really check interpretations to enable them to be, as I said, robust. And that's where kind of synthesizing other data sets into that equation allows us to make more informed interpretations. I don't want to bang on about it, but it is a large data set, and not in and of itself in the data, but in the visualizations it produces. They can be very complex to kind of view, particularly within an IT setup, which may not have specialist software in-house, such as you might find in a local authority where large parts of the authority are using conventional software, and it can therefore be complicated to, you know, exchange this, fully integrate this within the local authority setup. I also think we need to remember about how LiDAR is visualized in multiple ways, you know, and often, you know, we're viewing it rapidly, quickly in a hillshade, and actually, you know, taking a bit more time, processing things a bit more can actually produce, you know, much more interesting and much more, you know, interpretable results, essentially. So here, for instance, we might, you know, have a look at Old Oswestry Hill Fort as an example of where the hillshade model gives a hint of some of the features within what is, you know, arguably one of the country's finest hill forts, the ramparts on the western side, and the western entranceway with its you know, enigmatic pits going down the western side of the hill fort. It is a fantastic sort of hillshade model in and of itself, but there's hints of features inside, and just a little bit of processing, you know, pulling together multiple hillshades, for instance, allows us to start to see some of those features inside. So here you have a practice trench system basically emerging within the interior of the hill fort. You've got, you know, the full set of communication lines. You've got saps. You've got, you know, machine gun pits. You've got mortar craters emerging within the hill fort itself. A feature that had been identified previously through some aerial photography, but actually, you know, directly recordable through LiDAR when processed a little bit more. Another hill fort, another example of how some of these visualizations can move us forward. This is Burrow Hill Fort down at Hope. You know, a standard hillshade that we might see here, you know, from a single azimuth, you know, sort of it kind of gives us an impression of some of the impressive earthwork features, particularly in the eastern side of the hill fort. But when you start to kind of, you know, further process that, you do get real detail emerging of the hut platforms on the eastern side of the hill fort, and some of the quarry scoops inside the entranceways, very impressive entranceways that we can start to look at in more detail. And I found here particularly useful the 3D modelling of this, enabling you to rotate, to, you know, continue to move the light source around, really enables you to, you know, to pull detail out of these things. And I think we just have to have the proviso on all of this that, you know, this takes time, and often local authority, you know, historic environment responses are very time driven. So we often don't get the time to explore this in as much detail as we might want. I turn to another sort of emerging geospatial technology, which is really making a significant impact in the way we in the way we work within archaeology, photogrammetry. And we've seen a massive increase in projects which have been looking at building recording and monitoring. You know, we got Shrewsbury Town Wall conservation management plan with lots of Adam's photogrammetry within it. We have seen it used extensively for earthwork survey and for recording excavations as well. And we will have some examples of that later, no doubt. And in some instances, photogrammetry is actually being seen as the primary method of survey, rather than as complementary to perhaps more conventional survey we might see from earthwork survey. And again, I would say that that is not a problem in and of itself, and we are seeing traction within archaeology as that as the primary archive. But again, it's very much dependent on the quality of both the photographic work itself initially, and of the data captured through that process, and the way it's presented, and again, its integration with other forms of archaeological interpretation that kind of make it really, really powerful, particularly with regards to earthwork survey in the landscape. And I also flag up digital archiving yet again, that actually there are lots of open questions with regards to the best formats, the best way of archiving from these projects, and to make sure that these are accessible. These need to be reinterpreted. They are often needed for other projects. They are needed for, you know, purposes beyond which the initial survey might not have envisaged. So having an available digital archive in a non-proprietary format, available to people with, you know, perhaps less powerful computers, is actually kind of part of the equation. And I don't think it's been solved yet, and I don't think it will be, you know, necessarily easy to solve, but it's one we shouldn't shy away from, really. I want to very briefly, I know I'm sort of running to time, but I'll just very briefly kind of talk about some of these concepts in two castle studies I've been involved with recently, both funded by the Castle Studies Trust, and working with some of the people who are present here today. So on the left-hand side of that slide, we have Cawes Castle down near Westbury, and on the right-hand side, we have Castle Pulverbatch down just west of Shrewsbury. And basically, at both sites, we were keen to bring together different non-invasive survey techniques to try and understand the relationships between interpreting from geophysical survey, conventional earthwork survey, and photogrammetric survey as well. So we were throwing multiple techniques, you know, at both castles to try and understand how that influenced our interpretation of these features. And it was very much a nested program of using below ground non-invasive survey techniques as well as above ground non-invasive survey techniques to try and work out as much as we could say about these castles in an integrated manner. And you'll see here the practical problems. This is the huge motte at Cawes Castle, a conventional kind of earthwork survey had to be used here because of the accessibility of the motte to, you know, you're not going to be able to run a UAV effectively over this site, and, you know, given the density of the tree cover. So going in literally with alidade and tape and with GPS unit enabled us to build up a very comprehensive picture of what was going on within the inner bailey, the tree covered inner bailey of Cawes Castle. So comparing on the left the photogrammetric model, you know, with the tree cover at point A, you know, across the inner bailey, with the earthwork model conventionally hashed on the right hand side, showing the density of built heritage features, you know, the Great Hall, and all the sort of other gatehouse features, together with the motte within the inner bailey of Cawes Castle itself. I'll quickly move through that because I realise I'm to time. But the same method, you know, sort of same applied at Castle Pulverbatch, where we sort of, you know, collected data with a conventional earthwork survey. We collected it with a photogrammetric survey by UAV, and we combined that with geophysical survey, and it really strengthened our ability to interpret features on even quite a small castle site where you might imagine there's not much to be said. It actually allowed us to kind of integrate these methodologies to start to talk more about the development of this very small motte and bailey castle. And it really was a lesson in visualizing and processing this data. Very much needs to be geared about what you're trying to say and how you want to say it, because every visualization tells a slightly different picture. So there's a lot that can be done with the same data is really the message from that one. And I think it sort of ties into kind of wider methodological issues here. I quote from Bedford's, this is Historic England's guidance on photogrammetric survey, where they were sort of, you know, making the point that structure from motion or, you know, or photogrammetric UAV survey was a fantastic tool, but the key part of it was ground checking, and the survey before, during, and kind of after the actual photogrammetric survey was crucial in being able to sort of defend robustly your interpretations made from the photogrammetric model itself. And I think I'll leave you with a sort of comment from Michael Fradley. Sorry, this video might not load. Who was sort of someone involved heavily with conventional earthwork survey. He found, conversely, that going back to the photogrammetric model enabled him to sort of, having, you know, left the field, being able to check issues of interpretation related to his conventional earthwork survey model was absolutely fantastic and fundamental to his ability to interpret features across this site. I'll leave it there for you because I realise I've been going at quite a lick, and I'll hand back to Pascal and John to, you know, if there are any questions, happy to have them. I think we might have to keep to to time, I might delay the questions to sort of later on in the session, if that's all right with